Hey guys, welcome back to the Workplace and Apprenticeship 20 videos. This is lesson 1.3, talking all about rate of change. So we're first going to do just a quick recap. So your rate of change is essentially looking at a rate that's comparing two variables, where one is the independent variable and the other is the dependent variable. In class, I also showed you guys a formula for your rate of change. So your rate of change, which is also equal to your slope, is equal to your change in your dependent variable divided by the change in your independent variable. There is also another form that we can rewrite this, which is actually something that we're going to use in this lesson today. So we can also rewrite the change as your dependent. When we're talking about in terms of a graph, this is typically your y values. So your change in dependent is your second y coordinate minus your first y coordinate. And that's divided by the change in your independent. So that would be your second x coordinate subtract the first x coordinate. So now we're ready to move on to our first example in our lesson. And this one here will be using our very last form of the rate of change formula. So Doug wants to install angled shelves in a display case, so he is using a computer numeric controlled router, an automated woodworking tool to cut a groove in the sides of the display case. A CNC router uses coordinates to identify where the router should begin, which is point A if we're looking at our little picture over here, and it stops at point B when it's cutting a groove. Doug wants the cutter to begin cutting a groove at A, which is at 4 and 12, and stop cutting at B, which is at 14 and 28. So what are the slope and the length of the groove? So this one here is a two-part question. So the first part here is they are looking for your slope, and then in the second point they're looking for the length of the groove. So how long is it from point A to point B? So in our first part, we're going to be looking for our slope. And if you're ever stuck trying to figure out which part of your rate of change formula you should use, you really need to look at the information that you're given. So here we're using point A, which is a coordinate, and point B, which is coordinate. So going back up to our formulas, you can notice here that our very last form of the equation deals with coordinates. So that's kind of how you can tell to use your very last form of the rate of change formula. So first I'm just going to write down our information. So we know that point A is at 4 and 12, and point B is at 14 and 28. And I'm just also going to rewrite the formula. So your rate of change, which I'm going to label as ROC, is equal to y2 minus y1 over x2 minus x1. So when we're trying to figure out which one is y2, which one is y1, which is x2, which one's x1, I like to go ahead and label my coordinates. This here is my first coordinate, and your first number is always your x value, so that's your first x coordinate, and this second number here is the y value, so that's your y1, that's your first y coordinate. And you're going to do something similar for your b value. This one here is your second coordinate, so this is the second x value, and 28 is your second y value. As soon as you start to label your x and y coordinates, then you can plug it into your equation. So your rate of change is equal to y2, which we have labeled as 28, subtract y1, which is 12. That's divided by x2, which is 14, and subtract x1, which is 4. One thing that's really important about when you're dealing with fractions is that you can't do your division first, so you can't actually solve BEDMAS. You actually have to solve the numerator first and the denominator before you can start to divide any numbers here. So first, let's simplify our numerator. So we have 28 minus 12. That should give you 16. And 14 minus 4 is 10. Now this question here didn't state whether or not it wanted fractions or decimals. So to be fair, you guys could give me either the reduced fraction or the decimal form. So if you wanted the reduced fraction, just look for your common factor that can divide into both 16 and 10. And in this case, that number there is 2. So you can divide your numerator and your denominator by 2. And our reduced fraction should be 8 over 5. Or if we want to give the decimal form, you guys can divide 16 divided by 10. And in your calculator, it should spit out 1.6. So this tells you that the slope of the groove is 1.6. With that said, this is a word problem as well, so we want to answer this first part of the question with a sentence. I also am very open if you guys want to answer just both questions with one sentence at the very end. But just so that way I don't forget to write a sentence, I'm going to do that right now. So I will say, the slope of the groove is 1.6. And then I'm ready to move on to part 2 of the question. So just to scroll back up here, part 2 of the question is looking at the length of the groove. Now this one here actually takes us all the way back to even say grade 8 when you guys first learned about how to deal with the Pythagorean theorem. So this might not be very obvious at first, but what we can notice is that we have this long line here. And what we can do is if we connect or draw a horizontal line going straight out and then going straight up to point B, we'll notice that we get this awesome right triangle that I drew here. Use your imagination, please. But anyway, so what we have is we have this right triangle, which means that we can use the Pythagorean theorem to solve for our hypotenuse or length x. So in order to use your Pythagorean theorem, which as a quick recap, your Pythagorean theorem is a squared plus b squared is equal to c squared, where your c value has to be your hypotenuse, which is this length x. So in order to find length a and length b, we have to use the coordinates that were given. So looking at coordinate a here, we're at 4 and 12. So 4 represents your x values, which is your horizontal distance. So that means that the distance from the edge of your wood all the way to point A is 4. And then the horizontal distance to point B is 14. So from the edge of the wood to point B is 14. So to find out the distance between point A and point B, you just subtract the two values. So you take 14 minus 4, which will give you 10. So it means that the horizontal distance from point A to point B is 10 units. So I'm going to let that be our A value. Now we're going to do the same thing for the B value, and that one we're going to be looking at the vertical distance, so going from point A going up to point B. So starting here, we're at a Y value of 12, which is your vertical distance. So going from the bottom of your board to the A value is 12. And then going all the way up to your B value is 28. So to find the change in distance from point A to point B, you just take 28 and subtract 12. So 28 minus 12 is 16. So our B value there is 16. So fill this in for your Pythagorean theorem, and then just continue to solve like you have been for the past few years of your math education. So first we need to simplify our squared terms. So 10 squared, which is also 10 times 10, will give you 100, plus 16 squared, which is 16 times 16, or 256. And that's equal to c squared. Then we can simplify our left-hand side by actually adding those two numbers, and we should get 100 plus 256 is 356. And that's equal to your right-hand side, which is c squared. Then we want just c, but here we have c squared. So to get rid of a square, you have to do the inverse operation. And the opposite or inverse operation of a square is to do a square root. So you're going to square root both sides, and that will give you your answer for your c value or the length of your groove. When you put in the square root of 356 into your calculator, I'm just going to go to 2 decimal points here. And what we should find is that the square root of 356 is 18.87. And that's equal to just your c value. So from there, we found out what our x value is, or in this case, c, which is our hypotenuse. And that there represented the length of your groove from point A to point B. Now, to fully answer this question, we do need to have a sentence. And an example of a sentence could be the length of the groove is 18.87. And one thing that's really important here is that when we're talking about a length, we're usually talking about some sort of distance. And when we're saying 18.87, that doesn't really tell us anything. So when they do not specify the units, like say centimeters or inches, we should always write the word units. That way we know they didn't specify if it were centimeters or inches or yards. So it's just kind of one way to help tidy some things up. So once when you've written a sentence, included your units, you guys are all done this question. And that is it for this video. So thank you guys for watching.